The second video for lesson 5.6, we're going to talk about converting from a mixed number to an improper fraction, and then from an improper fraction to a mixed number. Let's start with the mixed number 2 and 3/4. Now, when we look at that, what we're going to think about it is 2 and 3/4. And we can continue looking at that as break the 2 into 1 plus 1 plus 3/4, which we can further break down to, well, when we look at 1, we know that 1 is 4 over 4 plus 4 over 4 plus 3/4. Now, if I add up my numerators, because remember, my denominator, my language is going to say the same. Okay, 4 plus 4 is 8, 9, 10, 11, 11/4. So 2 and 3/4 as an improper fraction is 11/4. Let's look at another example here. We've got 1. We have 1 and 5/8, which is 1 plus 5/8, which is, because our language is 8, it's going to be 8 over 8 plus 5/8, which would give us, our language is 8, and then 8, 9, 10, 11, 12, 13, 13/8. So 1 and 5/8 as an improper fraction is 13/8. Now that's the long way of doing it. I tend to do it the much quicker, shorter, and quicker way. And this is how I do it. Let's start with this fraction here, this mixed number. 3. For some reason my pen is not working very well on this side of the screen here. 3 and 1/6. And what I do is I make a half circle from the 6, and I go around the 3 back to the 1. And in between the 3 and the 6, I'm going to put a multiplication symbol. And then in between the 3 and the 1, I'm going to put the addition symbol. Which means I'm going to take 6, go around this circle here. And as I go, I'm going to take 6 times 3, and then I'm going to add 1. 6 times 3 is 18, plus 1 is 19. So my response is 19/6. Okay, if I have 4 and 1/2, again, I'm going to make my half circle, whoosh, put my multiplication symbol and my addition symbol. And then I go around my circle. 4 times 2 is 8, plus 1 is 9, and so it's 9/2. One more time. 6 and 1/5. Half circle. Whoop. Multiplication symbol, addition symbol. Now let's go around our circle. 5 times 6 is 30, plus 1, 31, and my language is 5. 31 over 5. Now, are you asking, Mr. Winkman, how did that work? Does that make sense? I don't understand. Well, let's do this the long way and then check and make sure. And let's just use this one right here. Okay? Let's do this. And I'm going to erase this. So we have 4 plus 1/2, which is going to be 1 plus 1 plus 1 plus 1 plus 1/2, which is going to be 2 over 2, whoops, plus 2 over 2, plus 2 over 2, plus 2 over 2, plus 1/2. Okay, that should be 2 there. So now we have 2, 4, 6, 8, 9, and our language is 2. So I have the exact same answer for both of those problems. Alright, now I'm going to erase what I just did so we have room for the second part of it. Alright, I had to kind of move things around a little bit because I was running out of space. Now, we're working now with converting an improper fraction to a mixed number. So let's start with an improper fraction of 9/4, or 9 over 4. Now, to do this, first thing we're going to do is take our 9/4 and we're going to subtract 4/4. And we're going to get 5/4. From 5/4, we still see that our numerator is larger than our denominator. We're going to subtract another 4/4. And we're going to get 1/4. Now here, our numerator is greater than is less than our denominator, so we're okay. So the question is, how many 1s did I take out along the way? Well, this 4/4 is 1. This 4/4 is 2. So I have 2 and 1/4. And that's what I have remaining. So let's look at this problem again, another example. I have 10/7. And the first thing I'm going to do, being my numerator is greater than my denominator, is I'm going to take out 1. So I'm going to take 10/7 less 7/7. And I'm going to get 3/7. Now my numerator is less than my denominator. But the question is, how many 1s did I take out? Well, 7/7 is 1, and there's no more, so our response is 1 3/7. Now, there is a shortcut, and it's the way that I normally do them. All right? And let's look at this example here, 12/5. Now, when we went from mixed number to improper fraction, we made it a half circle this way. Well, we're going to make a half circle this way this time. And all we're going to do is put divide. So how many times does 5 go into 12? Well, 10, 20, 15 is too big, so it goes in 2. If it goes in 2, that's 10. What's left over? 12 minus 10 is 2. It's going to be 2/5. All right, I'll show you what I did. I did 12 divided by 5, which is 2. Okay, 12 times 5 is 2 times 5 is 10. And so I had 12 less 10. I got 2 left over, and I put that over my denominator. Let's look at another one here. 8/3. So how many 3's can I take out of 8? Well, 3, 6, 9. 9 is too big, so it's got to be 6. That's 2. So I'm taking out my 2. 8 less 6 is 2/3. All right. Now this is going to be a little bit confusing, and this one takes practice. And unfortunately, there's not really an easy way to show this. I can show you visually what this means. You're taking away 1, you're taking away 1, 2. So 1, 2, 2, and 1/4. But when we talk about here, this is why knowing your multiplication facts is so important. Because you have to look at how many 3's are in 8. Well, 3, 6, 9, it's too big. It's got to be 6. So that's 2. And then we do 8 minus 6 is 2, and that's our remainder. You could look at it like this. Oops. 8 divided by 3 is 2, 6, 2, and then put that over 2/3. That's the way to do it, but I'm showing you more. I'm doing the mental math right here and taking care of that in my head. Alright, sorry this video was long, but we did have two entirely different processes that we were talking about. This is something that's going to be very important, and this is something that we're going to work on for a lot. And hopefully it's a review for most of you. If not, please talk to Mr. Winkleman and he will help clarify anything. Alright? Otherwise, talk to Mr. Winkleman, show him your notes, and he has a wonderful prize for you. Actually, it's not a prize, it's a gift. Alright?